So as we continue with complex numbers, I want us to look into the division of complex numbers in rectangular form. But before we go there, as we're going to rectangular form. So before we go to division in rectangular form, there's few things that I want you to note. A few things that I want you to know. So first of all, it's when, for an example, we are having division. So we're in division. For an example, let's say we have, let's say we have z all divided by, let me say 2. Yeah, I can say 2j. I want to start with one number over j. So let's say we have z equals to 2 over j. Yeah, let me start with it in that way because I want to deal with an example when you have a non-real number in the denominator. So if in the numerator we have at least a real number, so j is 0 there, so we have 2 plus 0j. In the denominator we have a real number which is 0, and the imaginary number is j. So how do we divide the two numbers so that at least we have it in the numerator and we have it in rectangular form, or sometimes as well as in polar form when you're done? So there's what we call, we need to multiply by radical of j using it as 1, or maybe let's not even say radical. So I want to put a note here on the side here that you will agree with me that we know 10 divided by 10 is equals to 10 divided by 10, that's 1. Then x divided by x is equals to, so it's equals to 1. So which means if we divide a factor divided divided by a similar factor, it's equals to 1. So which means we can divide any value by itself and we're still going to get 1. Or we can express 1 in many forms. So we want to try and apply that to, we used to call it is rationalizing the denominator in sense. So we want to get rid of j there. How will we do that? We need to multiply by j over j. So we still get 1. But in most cases, you'll see that because if we deal with complex numbers, we must make sure that we multiply by conjugate of that. But I'm going there, but with this one, I just want to leave it as it is. I want to leave the value as it is. So, but I just want to explain the rationalizing the denominator type. So in that case, when we simplify, 2 will multiply j according to fractions. Numerator multiplies numerator. Denominator multiplies denominator. So we'll have 2j all divided by what? J squared. And j squared is equals to -1. So j times j is j squared. Then j squared is -1. Then as now you'll see your answer, you'll be having, let's say, -2, -2j. So at least you have it in that part that the 0, it's a real part, the -2 is the imaginary part. So, but I wanted to explain when we're using, let's say, one vector. But we are not supposed to apply it in this way. We must make sure that we apply something which is called conjugate. A conjugate. Okay, I hope it's conjugate. So, for an example, let's say we have a complex number, 2 minus j. 2 minus j. So, a conjugate of that complex number will be equals to, we are going to change the sign between the real part and the imaginary part. So the sign between the real part and the imaginary part is minus, f is going to be positive. So that is the conjugate of 2 minus j. And conjugate of, let's say, 2 plus j, it will be 2 minus j. So we change the middle sign between the real number and the imaginary part. So accordingly, the terms accordingly. So sometimes you can have negative j plus 2. So do not change the sign. Please make sure you arrange them in order and then change the middle sign between the imaginary and the real part. So now I want to take maybe one example to explain that. Let's say, for an example, we have to simplify the following complex number with division of two complex numbers. So we have 2 plus 5j. 2 plus 5j. We need to simplify the following expression. Now, given that we see we have a complex number in the denominator, the method that we can apply is to apply what we call, again, as I was saying, the conjugate of the denominator. We use it as a 1. So must use it as a 1. So we're going to say multiply by. What is conjugate of 2 plus 5j? 2 minus 5j. All divided, divide by 2 minus 5j. So we were not supposed to use this as a 1. We're still going to have a non-real number in the denominator if we don't use a conjugate. So make sure you use the conjugate of this as a 1. Therefore, this still divides itself. We still get 1. So we just express using 1 to try and simplify. Therefore, according to multiplications of fractions, we're going to have, in fact, just treat it as a factor. So we'll have 1 times 2, which is going to be 2. 1 times minus 5, minus 5j. So minus j times 2, minus 2j. So minus, and minus is going to be positive. Then 5, I can put the j squared for now, but we know it's equals to negative 1. Then all divided by. Okay, I hope maybe by the look we know what is happening in the denominator. I hope you see we're having difference of 2 squares. I hope we still remember difference of 2 squares. Who doesn't remember? Difference of 2 squares. So if you recall difference of 2 squares, if let's say for an example we had x squared minus 4. When we factorize difference of 2 squares is x plus 2 and x minus 2. So I want you to see that it's like you'll be multiplying x and x, you get x squared minus 2 and positive 2, you get minus 4. So there's no need to get the middle term. The middle term is going to be eliminated, which is 2x minus 2x. So same thing here, we're going to have 10j minus 10j. The middle term is eliminated. So just say 2 times 2 and get 4. And say positive 5 times negative 5, we'll have negative 25. J what? J squared. I hope it's still clear. So the middle term is eliminated, the 10 and 10. I hope you see that. Okay. So 10j minus 10j is eliminated. So we can carry on and simplify the numerator. So please allow me to add the like terms. I hope you see j squared is minus 1, right? Minus 1 times 5, it will be minus 5. We will subtract from 2, where we're going to have negative 3. Then minus 5j minus 2j minus 7j. Then all divided by. I hope you know that j squared is minus 1 times the negative 25. It's positive 25. Then plus 4, where we're going to have 29. So 4 minus 25j squared is 29. J squared is negative 1 times negative 25 is positive, then we're done expressing our complex number. Notice I'm not expressing simplifying. Therefore, we need to leave it in a rectangular form. Okay, let me record. So in rectangular form, we'll have negative 3. Okay, we'll have negative 3 divided by 29. So negative 3 divided by 29, and minus 7 divided by 29j. So if you want, you can leave it in decimals. If you want, you can leave it in decimals.